Woohoo! We are live with Math 75 2.1, the introduction slash reminder slash review of quadratics. And in 2.1, what we're doing is solving quadratics algebraically. And the first page I had kind of reminded you about the quadratic formula and all that fun stuff. And on this page, we're actually going to do a problem that has is actually a word problem with quadratics. Woohoo! So we've got a profit function. So P of X equals, and you'll notice that it's written in an interesting way. And that is because mathematicians tend to hide minuses in between. If the minus is at the very front of an expression or a function or a polynomial, sometimes it falls off. So this book especially loves to put the x squared last. And I'm going to say for our purposes, I'm always getting yank it out and make it first. And remember that as long as everybody holds on to their own signs, we have commutative property for polynomials. Because we're adding the different signs. Even though this is subtraction, we think of this as the opposite of 0.01, and then we get away with it. Yes, it's semantics, but it works. Okay. Sometimes you have to be very quiet when you write out a polynomial. These things get complicated very quickly. So here's our polynomial. And the question we have is, what levels of production will yield a profit of $250? And what that means, yield means give you or equal. Basically, that's the verb there. So there's our equal sign. We've got to find the level of production. So level of production, this guy right there. Remember, that's just a fancy way to say X. And we want profit to equal 250. So I'm just going to do this. Which means that in order to solve this, pardon me, in order to solve this, I'm going to have to move this 250 over to the other side. So let's subtract 250 from both sides. Woohoo. Oops. Paper won't hold itself. And then I get 0 equals negative 0.01x squared plus 50x minus 550. Woo. So why did I go to all that extra trouble? Well, in order to solve quadratics, when you see you've got an x squared, remember that you're going to have a 0 on one side of the equation. And so once we've got the 0, then we are free to either factor. And if you're really good at factoring, this, I believe it does factor. I'm looking at it. I think it does. We'll have to find out. But what I'm going to do is I'm going to say, you know what? Factoring, not my strong point. So I'm actually going to approach this from the perspective of the quadratic formula, which I know everyone's like, no, don't do it, don't do it. We could totally do it. Let's try it. Okay, so if I've got 0 equals ax squared plus bx plus c, I wrote it backwards just so it matches up with what we've got. That's that's a quadratic equation in standard form. And I'm going to say that x equals the opposite of b plus or minus radical b squared minus 4ac all over 2a. So in our case, a is negative 0.01, b is 50, and c is negative 550. I know everyone's like, yay, those are wonderful numbers to work with. And I'm like, I know. And the sound of the alarm tells us we're doing it right. Okay, so let's go ahead and solve this sucker. So x equals the opposite of b, which is negative 50, plus or minus radical. Give myself lots of room, but I'm sure it's not even enough room. I am famous for just not giving myself enough room. I'm sure that's probably a really profound statement that I'm going to ignore so we can continue with the math. B squared, 50 squared, minus 4 times, yep, didn't give myself enough room, times a, which is negative 0.01, times c, which is negative 550. I can just go, yeah, like that, all over 2 times negative 0.01. Okay, this is This is a lot to look at. But basically, you just want to, from this point out in Math 75, make sure you have a calculator. Let me know if you don't have access to a calculator. We'll try to figure that out. But you want to get a calculator either on your phone or an actual lovely blue calculator. And let's go ahead and multiply this all out. I know that the alarm tells us that everything is very exciting right now. So let me try to see what's going on inside here. So I've got 2,500. And now notice I've got a minus times a minus times a minus. So I'm going to have a minus. And then 4. 22. Negative 0.02. Okay. So this is exciting, very exciting. I get negative 50 plus or minus radical, and this is 2,500 minus 22, so it's 2478 inside the square root. And I've got a negative 0.02. Oh, now I'm going to tell you that, I'll double check it, 2478. I believe 2478 is not a perfect square. No, it's very, very close to 50, but it's not exactly 50, and it isn't a nice, this is not nice. So here's where we would have to look to the problem for the rest of the instructions. Now, I took this problem directly out of the book. And as you notice, it doesn't give us any sort of indication about how to approach an answer. Now, if I were going to give this to you, say, on a test, I would say round to the nearest unit. And if I say round to, I'm not sure where the parentheses go actually on this one. That's a good question. Anyway, round to the nearest unit would mean that would be our hint that rather than using bare math, which would be so fun, but we're not going to use bare math on this one to try to suss out who's hiding inside of there. For example, it looks to me like, well, I'm actually not sure who might be in there. Oh, there's some 3s, there's some 2s. We'd have to see if there's anything we could really squeeze out of that radical. But if I say you're going to round anyway, you might as well just go full calculator on this. So I'm going to go ahead and say we've got 50 plus radical 2478 all over negative 0.02. Or negative 50 minus radical 2478 all over negative 0.02. And then let's look at the calculator. Can you look at the calculator? You can. Let's do that. Okay, so I'm going to put this straight in. First thing to talk about is the fact that this minus in front of the 50 is actually, let me see if I can extend your view a bit. A little bit. Okay, here we go. This is like a zombie calculator coming to get you. Okay, I know this is very, very bright. Let's see if I take it out completely. Oh, there you go. Okay, so we'll go with some blue, but this way there's less flare. Negative 50 right there. In order to put it into calculator, you can't use the regular subtraction. That will confuse the calculator. Humans see a minus and a negative and a subtraction and all the other things that the symbol can mean as all, they kind of blend together and we just deal with it. But calculators are not that smart, actually. And so the minus is specifically for subtraction. That means a number and then a minus and then another number. If you want a negative, you have to find somewhere on your calculator, you either have, like I do, and it's almost worn off because I hit it so many times, this minus sign in parentheses, or you might have a plus or minus key somewhere. So I'm going to start with that. Can you see the readout? You can. Okay, so it's negative 50. And already I could have made some other choices, but I'm going to go with it this way. And then I'm going to do plus, because I'm going to do the plus one first. Now on my calculator, square roots or radicals have to be done first. So I see the square root of radical right there, right? I don't know if you guys can see it. It's very faint, but it's right above the x squared. So I'm going to go in to do a second and then the square root. That gives me my square root and 2478. Now, different calculators have different tolerances for, shortcuts. This, because if you notice it started a parenthesis right there, it really wants you to close the parenthesis. But a lot of times, if you don't close your final parenthesis, it doesn't mind. Okay, I'm going to actually calculate that. And I got negative 0.5504 and some other things. Funny thing is, with the lights off, I can't see it. And then that's the numerator, and I'm going to divide by negative 0.02 and get the answer. And I get, let's see, I'm going to write it down here so I can copy it down, 0243 and some other numbers. Or, shall we do it again? Woohoo! Let's do it again. So for this one, it'll be negative 50. And then this is a true minus. The second to get the square root or the radical, 2478. Close the parenthesis, hit enter. Oops, you can't see that. Hit enter for equals. And we get negative 99.77, etc. And I'm going to divide by the opposite, or negative 0.02. And this one comes out to be massive. Let me pull it down so I can read it. 4988.9756. Okay, so I'm going to turn my light on just a little bit, get some more brightness going on in the world, and let's talk about these two answers. So these two answers represent X. Remember, X is a level of production, number of units. So it doesn't really make sense to talk about partial units. Like, I don't know if you would go to the store and buy half a burrito. So what we're going to do is we're going to round. And I think the first one, the rounding is pretty clear. I'm going to round down to 11. But on the second one, the second answer we got, this one is 0.9756. That seems pretty heavily weighted. If I look to the nearest unit, the next number is 9, so I'm going to round up. So I'm going to get 4989. Okay, so I've got two possible answers. And let's talk as a preview for the next section. Let's talk about what is going on. How did we get two answers? Because with lines, we only got one answer. So what's going on? Well, I don't know if you recall, but when we have, let me move this down a little bit so we can look at the original problem. When we have quadratics, we're going to get a parabola. This is going to be a sad parabola or a happy parabola. Now, if we look here at the sign of the coefficient of x squared, so the sign of the leading coefficient, if the sign on the x squared is negative, I'm going to push this back down again, then we get a frowning parabola. Woohoo, look at that. And in the next section, we're actually going to go through and graph them very carefully. But right now, this is just a sketch. And so what's happening is this is my profit. And I said we wanted the profit to hit right here. This would be at the level of 250. And so we're getting 1x right there, that's 11, and 1x right here at 4,989. So that's a sketch of what's going on. I didn't write in my axes or anything, just kind of to visualize. And part B is kind of interesting. Can a profit of more than $250 be made? Which is a random question, except this is a really good business question. Because if you know what the sketch looks like, and you know there are two values as answers, then you know that this line of profit is falling here, as opposed to, say, here. at maximum profit, the maximum profit would be way up here. And how many different values of x could we use to get to that profit? Well, the one that's at the very top has only a single value of x. And so the fact that we got two different answers and the fact that they're so far apart means, oh yeah, we could make way more profit than that. Somewhere here is this magic value. Now, I don't want to give away too much, but I could say some things about symmetry to suggest that if we know 11 and we know 4989, then we also know what this value is, because parabolas are symmetric. And so this should sit right halfway between. Now, there's going to be a little wiggling because what happened was we didn't get exact answers. We estimated by approximating. So it's going to lie exactly between these two, which may or may not give us quite the same answer. But my guess would be it would be somewhere around there. So the answer is yes. Yes, since or because we got two answers for x. Woo! Okay. So last thing I'm going to make a note of, you are welcome to use any technique for solving each equation, regardless of what the problem tells you to do. So if the problem says you have to factor, you're welcome to use the quadratic formula. If it says you have to use the quadratic formula, go ahead and use factoring if it's going to work. So please go with your own perspective on how you want to solve these things. Woohoo! Yay, we made it. Okay, I'll be back. Same bat time, same bat channel for 2.2.